And you can see what these things are. If you're just using the console, the most common commands to look inside your workspace, your session, to see what's there. ls, if you say ls, and again, it's a function, so you have to use the parentheses. ls is list. It'll show you, and I don't have anything. It returns, when I execute ls, it returns a character vector that's empty. And that's consistent with what we see up here. There's nothing in my workspace. I haven't created any variables yet. It's empty. Okay, there's another command. So ls returns the objects. ls is a synonym, I believe the name is, for another command, objects. Objects is the exact same command. It returns the variables. So ls and objects will show you the variables that exist in your session. There's also the command search, S-E-A-R-C-H, with the parentheses. Search also looks into your workspace, but instead of returning the variables as objects, search returns the packages and the data sets that are floating around in your session. And we see them down here. The packages are labeled. They are preceded by this header package. And these are the default packages. These get loaded every time you start a session. These are the bare bone minimums packages that you need to do basic things with R. And you'll notice that when it lists objects that are in your workspace, it lists them as a vector. This is not a coincidence. R assigns everything to a vector by default, even when it's showing you the objects that you have floating around in your workspace. And note also that the number 1, the first listed object in this vector when I execute search is .globalenv. That's your global environment. The global environment always has position number 1. It's always first, and it's a unique thing. It's a unique construct, and we'll talk more about that as we go through the course. When you do search, when you execute the search command, it lists the packages, but this order, the sequence of the packages is not, it is meaningful. It does have meaning. That is, if I call a function that is in one of these packages, it will look for that function by going through these packages in the order that they're listed here. It will look first in the reshape package because this is number 2, then it'll look in the plier package, which is number 3, then it'll look in grid, which is number 4, then it'll look in proto, which is number 5, and so forth. So the order of these packages can have an effect on your function calls and on your variable calls, and we'll talk about that as we go through it. Okay, so it shows you the structure, in effect. It's showing you the structure of your session, which is important to keep in mind. Okay, now watch what happens. Let's get rid of this histogram here. And watch what happens when we start to interactively create variables. Here we're going to create a vector, x, and I don't know how many of you are completely unfamiliar, but we probably should review this. This is an assignment operator. It looks like a backwards arrow. It's really 2 characters. It's a lesser than sign and a hyphen. This thing is called, this assignment operator is called the gets symbol, the gets operator, G-E-T-S. And it means that x gets this value. So this is an assignment statement. On the right-hand side of the get symbol, the assignment symbol, this is an expression. And so we can execute it by itself. What happens when I just execute that? It returns this vector 1, 2, 4. We're using the combine operator, the C operator, which is the most common way to create a vector. And we're creating an ordered vector of these 4 integers, 1, 2, and 4. And then we're going to assign it to variable x. So let's just execute the whole line. So I put my cursor in the line there and hit run. And notice what happens up here. Now we see that variable which has been created. Nothing is returned in the console. But we do see what's in our session up here in this tab, Workspace. And this is really a nice feature of RStudio. You can always be aware of the objects that are floating around in your workspace just by looking up here. And we can click on this object and it will show us what it is, or in this case how it was created. Okay, so we have that. So let's continue. So now we're going to create another vector Q, and note here I'm introducing two commands. Whenever you have the semicolon is telling R that the first statement ends and whatever follows is the next statement. So if I execute this line, in this case it returned the vector. We see it up here. Here's the vector. It both created it and returned it. That is, having the assignment statement with a semicolon and then repeating the variable name is the same as doing this. It's the same as having 2 lines where the first line is the assignment and the second line says evaluate this variable and return the value. So it's just a shortcut, and so we'll be using that a lot. Okay, and so then here we do ls again, and you can see those 2 variables. And if you say objects, you get the same. Search, again, just returns the packages. Okay, so the point I'm trying to make is that when R evaluates an expression, it prints the evaluation. And printing doesn't mean sending it to the printer. Print means it sends it to whatever the default printing device or display device is at the moment, which is the screen. When it prints a variable, evaluates a variable and prints it, it sends it to the screen and shows it to you. So whenever you just simply try and evaluate a variable, if I say, I want you to evaluate x, it will do that. That is the exact same command as saying print x. If I say print x like this, that also just simply sends it to the default device, which is the screen, and shows it to you. Now, another way you can short stop the non-printing characteristic of an assignment statement is by enclosing it in parentheses. So here's the assignment statement. So if I do this, that just simply repeated the x vector twice, and then added 8 to the end of it and put it in Q, but note it didn't print it. However, if I put that whole statement inside of parentheses like this, then it both performs the assignment. Let's give it a different name. We'll say J. It both performs the assignment and it prints it. So there's J. I've created a new variable J, and it shows it. It's showing it on the showing it on the screen. Why is it saying fix? I'm not sure. I wonder if there's something unique about J. Okay, well, let's go on. Okay, so we have X. If we look at X, go back to X. Here's X, right? 1, 2, and 4. We've been seeing these ones print out. Do the other elements of the vector have indexes? These are indexes. People refer to them as subscripts, but formally they're indexes. Do the other elements in the vector have indexes? Yes, they do. And you can access any individual element with the square brackets, unique operator in R. So if I say, which means, translates, tells R, show me that, the address, show me the value of the element that has that address as an index in this structure, in this vector structure. So if I say x3, it shows me the value of 4, which is the third element in X. If I say X, the sequence from 2 to 3, then it shows me the second and the third one. Okay, so what happens if we tried to run a function like this on a vector? If I say, what's the mean of X? It determines what it is, it computes it, and returns it just fine. If I say, what's the standard deviation of the vector X? Again, no problem. Most mathematical functions in R are vectorized. They're expecting a vector input instead of a single number. So even if it's a function like square root, let's try that. Not sure what the function is. Even if it's a function that only operates on a single number, it will perform it over and over again on each element of the vector, which is an important characteristic. Most math functions are vectorized. They expect a vector of elements to be input. Okay, so here we do an assignment, did that, show why. If you want to know data sets, here, if you just run the data, there are a lot of data sets that are available to you in packages. And if you want to know what they are, you can always just say data in parentheses like this. And here are the data sets that are automatically available to you. You don't ever have to load them. You can call them directly in a function without inputting them or loading a package or anything like that. So if you ever need a data set for a demo or to play around with, and you don't know what's there, you can issue the data command and it'll show you. Now, one of them is the Nile, so let's look at this. What is Nile? Here's Nile. Nile is a time series type data where it shows the flow, the volume of flow in the Nile River for 99 years, from 1871 to 1970, showing you some measure of flow of water. Okay, it's a time series data set which has particular characteristics. Can we compute a histogram? Can we plot it? Yes, we can. So here we run a plot, and we'll zoom that. You can zoom these plots, make them bigger. So here's our histogram, and it appears to be sort of normally distributed. Okay. Now, note that a histogram by default is not a non-parametric view. Histograms are useful to show, give you an idea of the shape of the distribution. It's a frequency distribution type plot. These bars are called bins.